What is up, Algebra 2? Here's your standard 9A summative test review. So we should know this unit circle pretty good. You're not going to have to do the whole thing. You're going to have to do one quadrant, but just for your review here, we have the whole thing. Okay, I'm not going to walk through the whole thing with you. We'll just pick one out. And I think I'm going to be boring and do quadrant 1. Do quadrant 1 with you, and you can pretty much bet that it's not going to be quadrant 1 on the test. So we'll have our 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Then we go through with our pi's. 0 pi, pi over 6, pi over 4, pi over 3, pi over 2. And then our coordinates, and I don't care, like we're kind of getting way out there. So if you want to bring your coordinates back on the inside, or if you just want to keep going out, whatever. We got 1, 0. Radical 3 over 2, comma 1/2. Radical 2 over 2, comma radical 2 over 2. Half, comma radical 3 over 2. And 0, comma 1. Okay, so whatever quadrant you get, you're going to have to go from axis line to axis line. Okay? So you should be able to fill in all 4 of those. Next, given a positive rotation, find the exact values of the 6 trig functions. So 5 pi over 3, I like to do a quick little sketch. 5 pi over 3 I know is down here. And so that's going to be half over negative radical 3 over 2 on the y. Remember that's sine, that's cosine. Okay, tangent is sine over cosine. So we have negative radical 3 over 2 over a half. We're going to multiply by the reciprocal times 2 over 1. And our 2's will cancel out, and we'll have negative radical 3. Okay, reciprocals. If I flip this, we'll have negative 2 over radical 3. We don't want to have a radical 3 in the denominator. So we'll have negative 2 radical 3 over regular 3. Half flips nicely to 2. And then if I have negative radical 3 and I flip that upside down to negative 1 over radical 3, again, we don't want to have that radical 3 on the bottom. And now we have negative radical 3 over regular 3. Alright, there we go. That's our positive one. Okay, our negative one. Our negative one. Okay, negative 7 pi over 4. We're going to rotate this way, all the way back over to here. Alright, if you don't like the negative rotations, okay, we're going to add a full 2 pi and push it back into the positives. A full 2 pi is a full circle, so it will still land in the same relative position. So to add 2 pi, I'm going to keep the same denominator, 4. So we have a common denominator. I'm going to double that, so it's 8. Put a pi. Okay, now see 8 pi divided by 4? That's going to reduce to 2 pi, so I'm adding one full circle. But we've already set it up so that this will add nicely to 1 pi over 4. And that's what this gap is. It'd be a positive 1 pi over 4 on the rotation. So 2 ways to think about it, whatever works better for you. Either way, we're at radical 2 over 2 and radical 2 over 2. Okay, tangent, radical 2 over 2 divided by radical 2 over 2. We have something divided by the same thing. It just looks funny because it's radicals and fractions. But if you have something divided by the same thing, 10 divided by 10 is 1. A million divided by a million is 1. Flipping these, if I flip that upside down, 2 over radical 2. Okay, again, we don't like to stop with the radical on the bottom. And now I have 2 radical 2 over regular 2. And those regular 2's cancel out. Yes, you have to do that. And now these will be radical 2's. Because they were the same thing. So they should have the same flip. And 1, if you flip 1, it's still going to be 1. So that's not a bad problem there. Okay, so we have our unit circle. We've got our positive rotation and a negative rotation. Okay, that should match the front side of your quiz that we did yesterday. So you know those are the first 3 problems. Okay, next page. We have a positive rotation and a negative rotation for you to do on your own. Let's do, I wanted to do one of these with you. Which one? Okay, 6a is pretty normal. There is one little complication here on 6b, or on 7a and 7b. So we'll leave this one for you to do on your own. Okay? There's one little extra sneaky step here on this one that we'll do. Okay? So this is our coordinate point 1, and then our radians. So we're at negative 6, negative 4. So that's going to be in quadrant 3. Negative 6, negative 4. Okay, now here's where the not fun happens. Negative 4 squared, negative 6 squared. That's going to be 16 plus 36 for 52. Now when we square root that to get what C is, you might be thinking, oh, it's just square root of 52. Think back to geometry and reducing your radicals. And this one reduces. So 52 would break apart into 4 times 13. That's going to be 2 radical 13. So it reduces. Okay? I can't promise that the test does or does not reduce. I don't remember. But I believe most of the problems we've had so far, I think this might be the first one that's reduced. Okay? And we'll see how that kind of changes things here. So when I go to do sine, and just so I don't have to write so itty-bitty over here, I might do most of these over here. Sine is going to be negative 4 over 2 radical 13. Okay, that's going to reduce to negative 2 over square root of 13. And then, of course, we don't want to have the radical on the bottom. So now we have negative 2 radical 13 over regular 13. So you can see where that one reducing does cause a little bit of like an extra half step for each one of these. Now having all this work here will make the flip ones a little bit nicer. Okay, because we were here and then we needed to fix it. But from here, if I flip that one, we'll have negative radical 13 over 2. I like to keep the negatives on the top. It's okay. If you put it on the bottom, it's going to be the same thing. Okay, let's do cosine. Cosine is going to be negative 6 over 2 radical 13, which reduces. Negative 6 divided by 2 is negative 3 over the square root of 13. And then we multiply by the square root of 13. And we'll have negative 3 radical 13 over 13. To do the reciprocal one, we're going to back it up to here, and we'll flip that one. And now the radical 13 is on the top. Again, I like to keep the negatives up there. Over 3 on the bottom. Tangent. Opposite over adjacent. We got negative 4 over negative 6. Negative divided by a negative. It's going to be a positive. 4 over 6 reduces to 2/3. And then 2/3 will flip to 3/2. Okay? Our angle in radians. And again, we changed it. We were talking about just this little corner of it. And we'll come back to talking about that. Right now, we're going to talk about the rotation from 0, 0, or from 0 degrees over to where we're at. That rotation. And it's on the bottom. We recommend doing cosine inverse. Cosine inverse, you can type that in, you can type that in, you can type any part of your cosine one in. Okay, and remember, if it's on the top, we'll keep it. If it's on the bottom, we do 2 pi minus whatever it was. That's why I like cosine inverse for this, because it's either the right answer right away or it's 2 pi minus the answer. So it's a pretty simple process. The other ones, you have a lot of thinking to do for each piece of it. So make sure we are in radian mode. We'll come back later in the unit, in one of the other standards for Unit 9. We'll probably be back in degree mode. And we're going to do second cosine, negative 3 divided by square root 13, arrow out of our square root, close our parentheses. Okay, we have 2.55 radians. We're on the bottom. This is going to be quadrant 3. So we have to do, I shouldn't put a star there. We are here. Okay? I didn't want you to get confused with that star and those stars. 2 pi minus 2.55. And we'll have 3.73 radians. Oops, switched pens. 3.73 radians. Okay, it does not have pi as part of it, so I do need you to write radians. If it had pi in there with it, then it's a little bit more obvious. Oh, we're talking radians. And if it does have pi in it, you're still more than welcome to write radians. But if you have pi in an angle measure, then I'm going to know you're talking radians. Speaking of degrees and radians, here's our last set of problems. Okay, converting radians to degrees. We got 11 pi over 20. To convert to degrees, we need 180 degrees over pi. The pi's will cancel out, and you can type that in, 11 times 180, and then divide by 20, 99 degrees. You could do 11 divided by 20, and then times 180. However you want to do that. We got 180, or 99 degrees. And you might get a decimal with those, that's okay. Converting to degrees, you might get a decimal. You might have a 0.5, a 0.25, something like that. Converting degrees to radians, now we need pi on top and 180 degrees on the bottom. That way our degree signs cancel. I like to do that, so that way I know I got it set up right. Okay, and we'll have negative 12 pi over 180. And you can maybe mentally reduce that by dividing everything by 2's and 3's. Or we can just ignore the pi for a second. Negative 12 divided by 180. And then we're going to go math frac. Math is the third or fourth button there. And then frac, and it's going to turn your last answer into a fraction for you. We got negative 1/15, and then we'll throw the pi on the top. Negative pi over 15. So if you have pi in it, I'm going to know it's radians, but you can still write radians. Alright, there you go. And you'll have 9a and 9b on your own. Okay, test is going to look just like that. Test is going to look just like your quiz. Okay, best of luck. We'll see you in class next time. Let me know if you have any questions.